At 7:42 a.m. on August 17, 1943, the air over Doadora airfield was already thick with heat and fuel fumes. A P-38 Lightning sat at the edge of the runway, engines idling, twin propellers chewing at the humid New Guinea air. Under its left wing, a mechanic crouched low, one hand resting on bare aluminum, the other still stained with grease that hadn't fully dried. Technical Sergeant James McKenna did not look up as the pilot climbed into the cockpit. He had watched this scene too many times. Lieutenant Robert Hayes was 23 years old. 6 combat missions. 0 kills. In less than 10 minutes, he would be airborne and flying straight into 18 Japanese fighters already climbing to intercept. The odds were not theoretical. They were written in the wreckage scattered across jungle clearings and along coral runways up and down the coast. In the past 6 weeks, 37 P-38s had not come back. The manuals said the Lightning was fast. The manuals said it was deadly at altitude. The manuals said never turn with a zero. Dive, fire, climb away. Hit and run. Do not get pulled into a turning fight. The manuals were correct. And the pilots were still dying. McKenna knew this airplane better than the men who flew it. He had serviced its engines, adjusted its control surfaces, signed his name at the bottom of maintenance logs that declared it fit for combat. He had watched pilots taxi out smiling and come back silent, or not come back at all. He had heard the same words from survivors over and over again. It felt slow. Just for a fraction of a second. Long enough to die. Inside the cockpit, Hayes ran through his checklist. Fuel. Mixture. Magnetos. Ammunition. He trusted the machine because he had been taught to. Because the system said it was sound. Because there was nothing else to trust at 20,000 feet. McKenna stepped back from the wing. There was nothing more he could do now. Whatever he had changed inside that aircraft was already set in metal and wire. If it worked, Hayes might live long enough to fire his guns. If it didn't, the Lightning would behave exactly as it always had. The tower cleared the runway. Hayes pushed the throttles forward. The engines roared. The P-38 surged ahead, lifted cleanly off the ground, and began climbing toward the waiting fighters to the north. McKenna watched until it was a silver shape against the sky. By every rule in the manual, this airplane should lose. So why didn't it? The problem was not a mystery to the men writing doctrine. By 1943, every American fighter pilot in the Pacific could recite the rules by heart. Do not turn with a zero. Do not slow down. Do not try to outfly an aircraft that was lighter, tighter, and designed to live inside a turning circle. The Mitsubishi A6M0 had earned its reputation early in the war, carving through heavier Allied fighters with ease. It bled almost no energy in a turn. It responded instantly. Against it, impatience was fatal. The P-38 Lightning was never meant to play that game. It was a machine built around speed and altitude. 2 engines. Twin booms. Heavy armament concentrated in the nose. At high altitude and high speed, it could dive like a hammer and hit harder than anything Japan could put in the air. On paper, the matchup made sense. The Lightning would choose when to engage. The Zero would never get the chance to turn the fight into a knife fight. That was the theory. Reality did not respect theory. In the skies over New Guinea, pilots rarely met the enemy on clean terms. Weather forced them lower. Clouds broke formations apart. Radio discipline collapsed in the chaos of combat. Zeros did not wait politely at altitude. They climbed into ambush positions, used the sun, used terrain, used patience. They baited American pilots with a single aircraft, then dragged them into turning engagements where doctrine became impossible to follow. Once the fight slowed down, the Lightning began to die. The statistics were brutal. In the 6 weeks leading up to mid-August 1943, the 5th Air Force had lost dozens of P-38s in combat with Japanese fighters. Many were not shot down immediately. They were hit while trying to escape, clipped while rolling out of a turn, caught for a heartbeat too long as the aircraft lagged between command and response. Survivors described the same sensation again and again. The airplane hesitated. Not always. Not enough to notice in training. Only under pressure. Only when pulling hard, rolling fast, fighting for position against an enemy who lived and breathed timing. Official reports pointed to pilot error. The explanation was clean. The doctrine was sound. The aircraft met its specifications. If pilots were dying, it was because they violated the rules. They turned when they should have climbed. They pressed attacks too long. They got greedy. That explanation satisfied headquarters. It did not satisfy the men on the flight line. Experienced pilots died the same way rookies did. Flight leaders with double-digit victories were lost in engagements they should have survived. Wingmen listened to calm, professional voices on the radio describe control inputs that did not produce the expected response. Then the transmission ended. The Zero pilots knew exactly how long a lightning took to roll. They had learned its rhythm. Learned when to reverse. Learned how much time they had to pull lead and fire. They exploited the lightning's behavior with surgical precision. Against that kind of enemy, there was no margin for delay. From the outside, the mission looked impossible. The aircraft could not be redesigned in the field. Engineering changes took months and traveled through layers of approval that stretched back to factories half a world away. No squadron commander had the authority to modify flight control systems. No mechanic was allowed to touch them beyond inspection and adjustment. The tolerances were written. The measurements were checked. Everything fell within acceptable limits. And yet men kept dying. The impossible part was not defeating the Zero. It was challenging the assumption that the system was right. To admit there was a flaw in the lightning was to admit that doctrine, manufacturing, and oversight had failed at the same time. It was easier to believe pilots were making mistakes than to believe a fraction of an inch in a control cable could tip the balance between life and death. Even if someone suspected the truth, the options were non-existent. A field mechanic did not submit design changes. He did not rewrite manuals. He did not override factory specifications. His job was to keep airplanes flying, not to question how they were built. The mission, as defined by the system, was clear and impossible. Fly the Lightning exactly as instructed. Avoid turning fights at all costs. Accept losses as the price of war. Wait for official improvements to arrive someday, somewhere down the line. But in New Guinea, pilots did not have someday. They had minutes. Sometimes seconds. Every morning, aircraft taxied out with the same limitations they had the day before. Every afternoon, fewer came back. The pattern was obvious to anyone who stood close enough to the machines to touch them, to feel the cables move under their hands, to hear the subtle differences that never appeared on a checklist. Fixing the problem meant breaking the rules. Not tactically. Mechanically. And no one, according to every regulation in the book, was supposed to do that. James McKenna was not supposed to matter. In the hierarchy of air war, he was invisible. A technical sergeant. An enlisted mechanic. A man whose name appeared only at the bottom of maintenance logs, written in pencil, smudged by sweat and grease. He did not fly missions. He did not brief tactics. He did not stand in front of maps with grease pencils and arrows. When aircraft returned with bullet holes, he fixed them. When they didn't return, he cleaned the empty space on the ramp and waited for the next one. That was his role. McKenna had been working on P-38s for 8 months by the summer of 1943. Long enough to know every sound they made. Long enough to tell when an engine was healthy just by how it settled at idle. Long enough to feel, through his hands, how control systems behaved when they were right and when they were only right on paper. He knew the pilots, too. Not their full stories, not their medals or hometown headlines, but the small details that mattered before takeoff. Who always checked his gloves twice? Who smoked while waiting for clearance? Who joked too loudly because silence made the fear worse? He watched them climb into cockpits with the same trust every morning, trusting that the machine beneath them would respond when it mattered. And then he watched too many of them not come back. The first time, he accepted it. Combat losses were expected. The Zero was a dangerous enemy. Everyone knew that. The second time, he told himself it was coincidence. By the fifth, he started listening more carefully to the men who survived. They all said the same thing. The airplane felt slow. Not broken. Not obviously damaged. Just slow in the moment that mattered most. A hesitation between thought and motion. Between command and response. A pause so short it barely existed, but long enough for a Zero pilot, trained to read timing like instinct, to put rounds exactly where they needed to go. McKenna mentioned it to an engineering officer once. Carefully. Casually. The way an enlisted man raised concerns without sounding like he was accusing the system of being wrong. The answer came back exactly as expected. Within specifications. The cable tensions were checked. The control surfaces were measured. The tolerances matched the manual. The aircraft was sound. If pilots were dying, it was because combat was chaotic and mistakes were inevitable. That answer closed the conversation. McKenna did not argue. He did not press. That was not his place. He went back to work, back to signing logs, back to sending aircraft into the sky. But the doubt stayed with him. It grew with every empty space on the ramp, with every helmet left hanging on a peg that no longer belonged to anyone. He began paying closer attention. Not to reports or charts, but to feel. To sound. When he tensioned control cables during maintenance, he noticed something subtle. A tone. A slight difference when he plucked the cable with a fingertip. Loose enough to be allowed. Loose enough to pass inspection. Loose enough to delay movement just a fraction longer than it should. He could feel it. Others could not. McKenna knew what that meant and what it didn't. It did not mean he was smarter than the engineers who designed the airplane. It did not mean the factory was incompetent. It meant the aircraft had been built for ideal conditions, not for desperate turning fights at low altitude against an enemy who had mastered every weakness. But knowing something and being allowed to act on it were very different things. McKenna was not authorized to change designs. He was not trained to question doctrine. If he was wrong and acted anyway, the consequences would be severe. Court-martial. Prison. A pilot dead because of an unauthorized modification. That kind of mistake did not fade into paperwork. It followed a man for life. And yet, doing nothing felt worse. Every day he chose silence, he watched another pilot climb into an aircraft that would behave exactly as it always had. He watched the same pattern repeat. The same assumptions. The same funerals that no one had time to attend. The doubt became unbearable. McKenna did not believe himself a hero. He did not think he was saving the war. He thought, very simply, that something was wrong and that the people who could fix it were too far away to see it. If he acted, he might save one man. If he didn't, he knew exactly what would happen. In that space between regulation and reality, between what was allowed and what was necessary, James McKenna stood alone. Not because he wanted to, but because no one else was close enough to the machines, or the consequences, to feel what he felt. And that doubt, quiet and persistent, was about to force him into a decision he was never meant to make. The flaw was not dramatic. That was the problem. There was no shattered component, no cracked fitting, no part that failed outright. The P-38 Lightning did exactly what it had been designed to do. Its engines produced power. Its wings generated lift. Its control surfaces moved when commanded. On every checklist, on every inspection sheet, the aircraft passed. The blind spot lived in the space between movement and response. Inside the Lightning's twin booms ran a network of control cables. Long steel lines routed through pulleys, guides, and fairleads, carrying a pilot's input from the stick to the ailerons. When everything worked perfectly, the system translated pressure into motion smoothly and predictably. But perfectly was defined by tolerances. Factory tolerances allowed a small amount of slack in the system. Not enough to register as a defect. Not enough to trigger maintenance action. Enough to account for thermal expansion, vibration, and wear over time. On paper, it was reasonable. Necessary, even. In combat, it was lethal. At cruise speed, the slack meant nothing. The forces involved overwhelmed it. The aircraft rolled as expected. Pilots never noticed a problem. Training flights reinforced confidence. The Lightning felt solid, heavy, stable. But turning fights were different. In a hard maneuver, especially at lower speeds, the aircraft lived in a narrow envelope. Every fraction of a second mattered. When a pilot slammed the stick to initiate a roll, the cable had to take up slack before tension reached the control surface. That delay was almost imperceptible. Almost. Against most opponents, it did not matter. Against a Zero, it was everything. Japanese pilots flew by timing. They knew how long it took an American fighter to begin a roll. They anticipated reversals. They planned shots based on predictable behavior. When a Lightning hesitated, even briefly, the Zero pilot already knew where it would be. The manuals did not account for that. Engineering models assumed ideal inputs and responses. Test pilots flew clean profiles at altitude. None of that reflected the chaos of a turning fight at low level, with energy bleeding away and pilots forcing the aircraft to its limits. James McKenna did not need equations to understand this. He felt it in his hands. When he tensioned cables during maintenance, he could feel the slack take up. He could hear it when he plucked the line, a duller note than it should have been. He knew the difference between something being allowed and something being right. The system did not recognize that difference. No warning lights illuminated. No gauges fluctuated. The problem did not announce itself. It waited for a moment of maximum stress and then revealed itself by doing exactly what it was designed to do. Delay. The blind spot was not ignorance. It was confidence. Confidence that specifications covered reality. Confidence that doctrine compensated for hardware limitations. Confidence that pilots could always avoid the kind of fight where the flaw mattered most. Confidence killed people. McKenna understood the risk of touching that system. Flight control modifications were sacred ground. One mistake could lock a surface, snap a cable, or introduce failure modes no one had considered. Mechanics were trained to respect that boundary, to never improvise. But improvisation was exactly what the situation demanded. The solution did not require new materials or complex redesigns. It required removing slack. Adding preload. Forcing the system to respond immediately, without hesitation, even under stress. McKenna knew how to do it. He had seen similar fixes in civilian machinery. Cars. Industrial equipment. Anywhere motion had to be transmitted cleanly and quickly. The principle was simple. Eliminate free play. Increase tension just enough to maintain control without overstressing components. The system resisted that idea because it lived outside the manual. The blind spot was not technical. It was institutional. No one in the chain of command could approve such a change quickly. Even if they believed him, the process would take months. Data. Tests. Reports. By the time an answer arrived, dozens more pilots would be dead. McKenna did not see himself as smarter than the engineers who designed the Lightning. He saw himself as closer to the consequences. He had watched men die because an aircraft responded a fraction too slowly. He had signed off machines that met every requirement and still failed their pilots at the worst possible moment. The blind spot existed because no one was standing where he stood, feeling what he felt, watching what he watched. The danger of his insight was not that it was wrong. It was that it could not be proven safely. The first aircraft to receive a change would become the test platform. The pilot would become part of the experiment. If the modification failed under load, there would be no second chances. McKenna knew this. He also knew that doing nothing was a guaranteed outcome. The Lightning would continue to hesitate. The Zero would continue to exploit that hesitation. The loss reports would continue to stack up with the same explanations. Pilot error. Combat conditions. Bad luck. The blind spot survived because it was invisible to the people who could fix it officially. It lived in the gap between design intent and battlefield reality. Only someone with grease on his hands and names in his memory could see it clearly. By understanding that gap, McKenna reached a conclusion that would have terrified any engineer. The Lightning did not need a new engine. It did not need new tactics. It needed one small, forbidden change. And once he saw it that way, the decision stopped being theoretical. The decision was made at night, when no one was watching. The maintenance hangar at Doodora fell quiet after 2,300 hours. Generators hummed in the distance. Insects rattled against the lights. Most of the crew had turned in, leaving only the smell of fuel, oil, and hot metal hanging in the air. This was the hour when regulations mattered least and consequences mattered most. James McKenna worked alone. The P-38 sat with its panels open, the aircraft still warm from the day's sun. Inside the left boom, the aileron control cable ran exactly where the manual said it should. McKenna pulled on it with both hands and felt the slack take up. The same slack he had felt on every Lightning that had gone to war and come back damaged, or not at all. He did not rush. If he rushed, he would make a mistake. From his tool bag, he pulled a short length of piano wire salvaged from a damaged aircraft weeks earlier. It was not meant for this. That was the point. It was strong, resilient, and never approved for flight control systems. Using it would violate multiple maintenance regulations at once. McKenna bent the wire slowly, shaping it into a tight Z. His fingers slipped. The wire fought back. He cut his thumb and wiped the blood on his coveralls without stopping. The shape had to be exact. Too much tension and the system could bind. Too little and nothing would change. This was not engineering. It was judgment. Installing it was worse. Space inside the boom was tight. He worked one-handed, flashlight clenched between his teeth. He dropped the clevis pin once and spent several minutes searching by touch, heart pounding, listening for footsteps that never came. If an officer walked in now, there would be no explanation that saved him. He connected the wire between the cable end and the pulley, reassembled the linkage, and pulled. No slack. The control surface moved immediately, clean and direct. The difference was unmistakable. McKenna tested it again. And again. He was adding only a fraction of a pound of tension, but it was enough to erase the delay that had killed men. He sat back on the hangar floor and stared at the aircraft. If this modification failed in the air, there would be no investigation that praised initiative. There would be charges. A dead pilot. An unauthorized change that ended careers and lives. McKenna understood that better than anyone. But he also understood something simpler. If he did nothing, the pilot scheduled to fly this airplane in the morning would face the same odds as the men who had died before him. That choice was no choice at all. McKenna closed the panel, wiped his tools clean, and left the hangar just after 0100. He did not sleep. He lay on his bunk staring at the ceiling, replaying every step, every measurement made by feel instead of instruments. At dawn, Lieutenant Robert Hayes arrived for pre-flight. 23 years old. 6 missions. 0 kills. Hayes did not know what had changed inside his aircraft. He trusted the system because that was the only way to climb into a cockpit and push the throttles forward. McKenna watched him from a distance, said nothing, signed the log as if nothing were different. Because officially, nothing was. At 0742, Hayes took off. McKenna stood on the flight line and watched the P-38 climb away, its twin engines pulling it toward the sky where Zero fighters were already forming up. There was no way to call him back now. No way to explain. No way to undo the decision. Breaking the rules had not produced victory. It had only committed them to whatever came next. If the modification worked, Hayes might live long enough to fire his guns. If it didn't, McKenna would have to live with knowing exactly why. Either way, there was no turning back. The engagement began at 0814. 4 P-38s crossed the coastline at 13,000 feet, sunlight behind them, clouds below. Lieutenant Robert Hayes flew third position, eyes scanning the empty blue ahead, heart rate already climbing. He knew the numbers. He knew the odds. 18 enemy fighters had been reported climbing from the north. There would be no clean approach. The call came suddenly. Bandits. 12 o'clock low. The formation rolled in. Hayes pushed the nose down and felt the familiar weight of the Lightning accelerate. Airspeed climbed past 300 knots. The Zero he selected grew fast in his gunsight, green and white markings flashing as it began its brake turn. Hayes squeezed the trigger. Tracers reached out. Most missed. A few sparked off the enemy's wing. The Zero snap rolled and dove. Hayes rolled to follow. And something was different. There was no hesitation. The stick moved and the aircraft answered instantly, as if the delay he had learned to anticipate simply did not exist. The Lightning rolled through 90 degrees faster than he expected, faster than it ever had before. Hayes corrected instinctively, brought the nose down, and suddenly the Zero was still there. Still inside his sight picture. He fired again. The burst walked up the Zero's fuselage from tail to cockpit. The engine detonated in a flash of black smoke and debris. The aircraft rolled inverted and fell away toward the jungle. Hayes did not shout. He did not celebrate. His mind was already processing the impossible. The airplane had obeyed him. There was no time to think about why. More bandits high, his wingman called. Hayes looked up. 3 Zeros were diving on him, sunlight glinting off canopies, closing fast. Every lesson he had learned told him to run. Build speed. Dive away. Do not turn. But the geometry was wrong. They were already too close. Hayes reversed. He hauled the stick and felt the Lightning snap around with a violence that startled him. The aircraft came through the turn clean and tight, bleeding less energy than it ever had before. One of the Zeros overshot, sliding wide, its pilot expecting a slower response. Hayes fired. The Zero's wing folded inward and separated. The aircraft disintegrated in a spray of fragments that rattled against the P-38's right boom. 2 kills. Less than 30 seconds apart. The remaining 2 Zeros split and tried to scissor, alternating turns to force Hayes into an overshoot. It was a textbook trap. One that had worked again and again against Lightnings flown by better men than him. Hayes stayed with them. Each reversal came faster than expected. Each roll responded immediately, no lag, no mushiness, no fight in the controls. The airplane felt lighter, sharper, alive. It went where he pointed it the moment he pointed it there. 1 Zero reversed too hard, bled too much speed. Hayes got inside the turn and fired from close range. The enemy aircraft came apart, pieces flashing past his canopy. 3 kills. In less than 2 minutes. The 4th Zero disengaged and ran. Hayes did not chase. His fuel state was dropping. Ammunition was low. He climbed back to altitude, hands shaking, breath ragged, trying to understand what had just happened. The fight had lasted 7 minutes. From 15,000 feet above, other pilots had been watching. They had seen Lightnings fight Zeros before. They knew what that looked like. They knew how it usually ended. What they saw now did not match anything in their experience. Hayes's aircraft rolled faster than it should have. Reversed quicker than physics said it ought to. It was not pilot skill alone. It was mechanical. When Hayes landed at 0903, James McKenna was waiting. Hayes shut down the engines and climbed out of the cockpit, legs unsteady. He walked straight toward McKenna, helmet still under his arm, sweat streaking his face. "It worked," he said. 2 words. No explanation. None was needed. Other pilots gathered quietly. Questions started immediately. Hayes shrugged them off. He did not know what had changed. Only that his airplane had responded in a way it never had before. Someone mentioned McKenna's name. Someone else watched the mechanic's face carefully. Later that morning, a flight leader cornered McKenna in the maintenance area. He asked one direct question. "What did you do to that airplane?" McKenna did not deny it. He explained the modification in plain terms. The slack. The tension. The wire. The risk. He did not dress it up. He did not ask for permission. The pilot listened, then nodded. "Do mine," he said. By nightfall, McKenna had made the same change on another aircraft. Then another. Each time, the risk multiplied. Each time, the results spoke for themselves. Pilots came back talking about roll rates and control response, about lightning behavior they had never felt before. Word spread quietly. No reports were filed. No officers were informed. Crew chiefs learned how to make the modification and how to remove it before inspections. The change moved from aircraft to aircraft, mechanic to mechanic, carried by whispered conversations and shared experience. The Lightning was changing. Japanese pilots noticed within days. Tactics that had worked reliably began to fail. Reversals that should have been safe suddenly weren't. Zeros found themselves overshot, outturned, shot down by aircraft they believed they understood. The timing they relied on betrayed them. For the first time in months, Lightning pilots began returning from missions with kills instead of excuses. But the success carried a shadow. Every modified aircraft was flying with an unauthorized change buried inside its structure. If one failed, if a control jammed or a cable snapped, the backlash would be immediate and brutal. The same system that had ignored the problem would punish the solution without hesitation. For now, control was held. The balance had shifted, quietly and dangerously, and no one knew how long it could last. Control never stays hidden for long. By early September, Japanese pilots knew something had changed. They did not know what, but they felt it in the air. Engagements that should have been predictable were turning violent and fast. P-38s were reversing direction sooner than expected, rolling inside turns that had once been safe. Timing, the invisible foundation of Zero tactics, was collapsing. For Japanese pilots, timing was survival. They had spent 2 years mastering the behavior of enemy aircraft. They knew when to commit, when to wait, when a Lightning would hesitate just long enough to be punished. Now that hesitation was gone. The Americans were not flying differently. The machines were. The first reports filtered back cautiously. Pilots complained that Lightnings were more aggressive. That they responded faster. That old tricks no longer worked. Command dismissed it as exaggeration. Stress. Fatigue. Losses had a way of rewriting memory. Then experienced pilots began to die. On September 3, a veteran ace engaged a P-38 using a maneuver he had executed dozens of times before. He baited the American into a turn, waited for the familiar delay, then reversed. The lightning reversed with him. Too fast. The near collision forced him into a desperate dive. He survived, shaken, certain of only one thing. The enemy he was fighting was no longer the one he understood. Japanese tactics shifted. Some pilots stopped pressing turning engagements altogether, switching to hit-and-run attacks that surrendered their greatest advantage. Others became more aggressive, closing distance faster, taking risks that would have been unthinkable weeks earlier. Both approaches increased losses. The Zero was no longer dictating the fight. In New Guinea, the modification spread faster than McKenna ever intended. By mid-September, dozens of P-38s were flying with increased cable tension. The change remained unofficial, invisible, passed hand-to-hand by mechanics who had watched too many pilots die. They removed the wire before inspections and reinstalled it afterward. It became routine. Dangerous, necessary routine. But the more aircraft that flew modified, the harder secrecy became. Maintenance officers noticed inconsistent readings. Cable tensions that did not match expected wear patterns. Aircraft that behaved too well for their recorded condition. Questions were asked quietly. Answers were vague. No one wanted to be the first to point a finger at something that was clearly working. Then the losses reversed. In July, American squadrons had lost 2 P-38s for every Zero destroyed. By August, the ratio narrowed. By September, it flipped. Lightnings were killing Zeros at better than 1-to-1 rates. Pilots came back alive. Morale shifted. Confidence returned. The system could not ignore that. An inspector at Doadora finally traced the discrepancies to their source. He found the wire. 6 inches of piano wire, bent into AZ, hidden where no factory drawing showed it. He wrote a report and sent it up the chain. For 3 weeks, the report sat on desks. No one wanted to touch it. Punishing the mechanics meant admitting the aircraft had been flawed. Approving the modification meant acknowledging that enlisted men had solved a problem engineers had missed. Both options threatened careers. Both challenged doctrine. While officers debated, pilots continued flying modified aircraft and continued surviving. Control, once lost, was now contested. In October, Lockheed engineers arrived quietly. They tested the modification. Measured tensions. Ran flight profiles. What they found was uncomfortable and undeniable. The fix was sound. The stress loads were within safe margins. The Lightning should have been built this way from the start. The engineers wrote their conclusions carefully. The modification was integrated into later production models. Officially, it was the result of engineering refinement. McKenna's name did not appear in any document. There were no commendations. No medals. No acknowledgements. The system absorbed the solution without crediting its source. By then, the Zero's advantage was gone. Japanese pilots, once dominant in turning fights, were ordered to avoid P-38s unless they held overwhelming numerical superiority. The hunter had become the hunted. Confidence eroded. Tactics shifted toward survival rather than aggression. The psychological edge that had defined early air combat in the Pacific was broken. James McKenna returned to his routine. He kept fixing airplanes. He kept signing logs. He never spoke publicly about what he had done. Officially, he had done nothing at all. He finished the war as a mechanic and went home to California, where he spent the rest of his life working on engines that never tried to kill the people using them. The pilots remembered. Robert Hayes survived the war. He flew 63 combat missions and shot down 11 enemy aircraft. Every year on August 17, he called McKenna to say thank you. No speeches. No explanations. Just gratitude. History moved on. The war ended. New aircraft replaced the Lightning. New doctrines replaced the old. The piano wire fix became a footnote, then a rumor, then silence. When McKenna died, his obituary mentioned only that he had been a mechanic. The control he had seized was never truly his. It belonged to the men who lived because he had broken the rules, and to the system that quietly took his solution and moved on without him. In war, control is never permanent. It is borrowed, paid for, and often forgotten. The war moved on without stopping to explain itself. By the end of 1943, the P-38 Lightning was no longer the aircraft Japanese pilots expected to dominate in a turning fight. New production models rolled off assembly lines with refined control systems. Manuals were updated quietly. Doctrine adjusted itself without ever admitting it had been wrong. Officially, progress had been made. Unofficially, lives had been saved long before the paperwork caught up. James McKenna received nothing for it. No commendation. No citation. No mention in after-action reports or engineering summaries. The improvement was credited to analysis, testing, and design refinement. The system corrected itself the way it always does, by erasing the fingerprints of the people who forced it to change. McKenna finished the war as he had begun it. A mechanic. He went home to California in 1946 and returned to working on cars and engines. He opened a small garage. Fixed what was broken. Charged fair prices. Lived quietly. When asked about the war, he said he fixed airplanes. That was all. The pilots carried the memory instead. Robert Hayes survived 63 combat missions. 11 confirmed kills. He never forgot the morning his airplane answered him without hesitation for the first time. Every August 17, he called McKenna. Not to relive the fight. Not to retell the story. Just to say thank you. The call never lasted long. Others remembered too. Flight leaders who had watched Lightning suddenly outturn Zeros. Crew chiefs who learned, without being told, when rules mattered and when they didn't. Japanese pilots who survived long enough to understand that something invisible had shifted against them, and that the sky was no longer theirs. History recorded none of that cleanly. It recorded models, dates, production changes. It recorded kill ratios and operational summaries. It did not record the quiet moment when an enlisted mechanic decided that watching men die was no longer acceptable. The legacy of that decision was not a new weapon or a new tactic. It was proof. Proof that wars are not changed only by generals or engineers. They are changed by people close enough to the consequences to act when the system cannot. People willing to accept punishment if they are wrong and anonymity even when they are right. James McKenna never claimed credit. He never asked for it. His name faded the way most names do, replaced by cleaner narratives and official explanations. But every pilot who came back alive because an airplane responded a fraction of a second faster carried that legacy forward, whether they knew its source or not. In war, victories are measured in territory and numbers. Survival is measured one decision at a time. And sometimes, the difference between loss and survival is not a new doctrine or a better machine, but a man who breaks the rules quietly, correctly, and disappears before history notices.